Due to the owner's severe overloading and flooring the gas pedal, the gearbox's pinion gear stripped its teeth on the spot. The owner initially thought it couldn't be repaired, but after a preliminary inspection, the craftsman confirmed it could be restored with a simple part replacement technique. Since the owner provided replacement parts, the repair process became much simpler. The craftsman fixed the damaged pinion gear on the lathe and planned to remove all the broken teeth. However, since the hardness of the pinion gear is quite high and the threading tool couldn't cut through, the craftsman had to heat treat it using an acetylene torch. The heat softens the metal through annealing, allowing the lathe tool to cut smoothly as if slicing through mud. Although the process is a bit tedious, it's actually quite satisfying to watch. After removing the damaged threads, the craftsman left a protrusion on the shaft for the joint. Precise measurements with a caliper ensured the shaft wouldn't be overcut. Since the two pieces would be joined with threads, the craftsman made markings on the shaft using a marker before starting the threading process. This made it easier to track the progress of the threading. The craftsman carefully controlled the tool's depth and cutting speed to ensure the threads formed gradually as planned. Once the threads were cut, the excess material on the shaft was removed to avoid problems during the future joint. At this point, the replacement pinion was ready. Next came the process of machining the other pinion gear, which was the reverse of the first one. The second pinion gear was also fixed on the lathe and heat-treated with an acetylene torch. Then, the worn-out section was carefully cut away. Since a joint step was already prepared, the shaft also needed to be drilled. The craftsman used different-sized drill bits to progressively enlarge the hole, and after determining the correct depth, he used a reaming tool for finer work. Each step was measured with a caliper to ensure precision and avoid any size discrepancies. When the hole diameter matched the outside diameter of the joint, threading was added inside the hole, allowing it to fit with the external threads of the other pinion gear. The threading process was performed smoothly, with no errors in precision. Once the threading was complete, the two parts were screwed together, and the connection felt perfectly smooth, indicating the accuracy of the machining. After assembling the two pieces, the craftsman started the lathe to check the alignment of the pinion gear. After confirming everything was in order, the final welding process began. Since the joint area had been beveled in advance, the craftsman only needed to weld along the seam. During welding, he paused frequently to hammer off the slag, which helped relieve the internal stress caused by welding and prevented impurities from getting into the weld. After welding, the craftsman smoothed the weld seam to match the original factory diameter. Finally, for added aesthetics, he polished the entire pinion gear. The pinion gear, which had originally been broken in two, was fully restored through precise machining and welding. So, what do you think of the craftsman's skills? If you had to rate him out of 10, how many points would you give?